Welcome to Find Bugs Unraveled Part 3. Alright, so far we have seen what static code analysis is all about. We have also discussed about find bugs, false positives, and two different methodologies for overriding the issues encountered while dealing with false positives. Now, let's discuss more about one important feature that plays a role in software development, that is security. It is not just about the security feature an application provides as a whole. Well, it is also about securing software code. So, in order to do that, the authors of Securing Java Code, Heuristics and an Evaluation of Static Analysis Tools are suggesting a new taxonomy for correlating coding heuristics with the design principles. So here is the taxonomy that is suggested by the authors. We have design principles at the top level of abstraction. They are basically the characteristics about design. For example, a software design shouldn't be too rigid that every change affects other parts of the system. Secondly, a software shouldn't be fragile. That is, when you make a change in one part of the system, it shouldn't break the other parts of the system. And finally, the software design shouldn't be immobile that makes it harder to reuse. At the next level, we have design heuristics, which are language-independent rules for creating designs that help to satisfy design principles. Then at the third level, we have coding heuristics, which are rules for writing code that helps to achieve design heuristics. Next, let's talk about a part of taxonomy that is specified by the authors in this paper. So, even when an application is about to throw an error, there needs to be a secure way to handle it. They call it secure failure. Let's talk about SF1A in detail, for example. So it says avoid catching overly broad exceptions such as java.lang.exception. This coding heuristic suggests that all the exceptions need to be handled individually instead of using a broad exception class. By following this explicit way of handling the exceptions, we can ensure the principle of secure failure is followed, as the developers would get a chance to understand each and every possible way the code would fail. Now let's see sample bug patterns that are used in find bugs. For example, the first one, DM, hard-coded constant database password. So this actually creates a database connect using a hard-coded constant password. Anyone with access to either the source code or the compiled code can easily learn the password. Second example, DM empty database password. This code creates a database connect using a blank or empty password. This indicates that the database is not protected by a password. Next, let's do a comparative study of different static analysis tools. So, the source for this comparison is taken from Static Checking Java with the Java Static Checker conference paper. Here in the first row, we talk about the code that is analyzed. And basically, we are comparing three different tools: Findbugs, JLint and JSC, the Java Static Code Checker. So code, this talks about the code that is analyzed. It is said in this paper that Findbugs does both source code and binary code analysis. However, my verifications in the official website for Findbugs proves that Findbugs is completely based on bytecode analysis, while JLint is based on bytecode analysis and JSC is based on source code analysis. Second row, the type, talks about the type that is the overall methodology of the tool. Findbugs uses pattern matching technique, while JLint uses syntax or semantic type technique, and JSE uses class technique. Third row, the direction. This row talks about the direction of data flow analysis. Findbugs uses both forward and backward data flow analysis, while JLint and JSE uses forward data flow analysis. Fourth row, alias, talks about the references that is coming from the same location in the memory. All the three rules doesn't use alias. All the three tools doesn't use alias. Fifth row, sensitivities. This row talks about data flow sensitivities. Both Findbugs and JSE uses path, flow and context data flow sensitivities, while JLint uses path and flow data sensitivities. So by now, I hope I have spoken pretty much about Findbugs and its underlying concepts. I hope this series had been informative to you. Thank you.